Hello, and welcome back to Mr. Powers Teaches Statistics. I've done this before, but I want to do it again. This is a how to use GeoGebra video on inferences with two populations. In this case, what are we looking at? We're using it to test the claim that the mean height of one population is less than the mean height of another. So I want to compare means. And I've done this before using GeoGebra, but since the first time I've shown this, I have found a quicker way to do it. The way I showed it before was fine. It's a good way to do it, but I just had to show this way. It's so much faster. So just like before, I'm in spreadsheet view, no algebra view this time. I don't need it. I'm just going to go with spreadsheet. We enter our data in row 1 or column 1 for the first row, column 2 for the second row, and we're going to highlight all that. We're going to click on our first button here on the top right, and we're used to doing one row or two, go one variable analysis, or do a two variable regression. But we don't do a lot with a multiple variable analysis, and that is exactly what we want to do. And it's going to do some things over here. We got some options, made some stacked box plots. I could click on this, and there's nothing else, but oops. Anyway, there's this button here, the Show Statistics button. We can still click on that, and then I get this window pop up at the bottom here with all of this extra information, which is really, really, really nice. Oh, and that just killed it there. Sorry, I'm trying to get it all to fit. Zooming in. Okay, that's a little bit better, just so make it nice and big. And so what we get is, it'll tell us right here with the statistics. This popped up at the bottom here with all this really awesome information about each row. It says, hey, we got A1 to A12. Oh, A1 to A15. But N is 12. So it says, okay, we got 12 values there. That's the mean of those values. And then 15 values in my second column. That's the mean. And it gives me standard deviations, quartiles, all this fun stuff, right? The statistics. But if we click on that, we get options. We get a lot of options here. And we can do that t-estimate difference of the means. So we can compare the means, not estimate. I'm sorry. I wanted to do the t-test, difference of the means. But you see, and we could also do paired differences. So if we have paired data, we can use this also for that. So it's really nice. I'm just going to show it with the means for now. But it's useful to remember, hey, you can do this for paired data too. It'll cut down a little bit on the time it takes to do these. So I click on that. Oh, stupid there. Okay. And then we can do our test, right? Null hypothesis is the means are the same. Our alternative hypothesis, well, they're different. Well, let's see. Can I go ahead and check to see, well, what was our hypothesis, right? I didn't even read this very well. This is an old example from a previous video, so I figure I'll use the same one. It says a 0.5 level significance, okay. Test the claim that the mean height of the 1988, so mu1, is less than mu2. So in other words, mu1 minus mu2 is negative. Okay, so mu1 minus mu2 is negative. That is, what here? So less than 0. That's our alternative hypothesis. That's what we want to find out. Is that true? And we get a p-value of 0.0545. So we would say, nope, unfortunately, not with a level of significance of 0.05. We fail to reject our null hypothesis. And we're going to have to just leave it at that. So we cannot conclude that the mean of our first population here, our first sample, we can't support the claim that the mean height of the 1988 population is less than the mean height of the 2012 population. And so let's see if it does right. Did it work just like before? This is the data we had before, 0.0545. Yeah, 0.05457. Yep, it's perfect. So it works out great. T-values there, everything. Not sufficient evidence to support the claim. The mean height of the 1988 male population is less than the mean height of the 2012 male population. There you go. So it's super easy to do. And if you wanted to go ahead and do a t-estimate difference of the means, you wanted a confidence interval, well, there it is too. It's so incredibly easy. And it's going to show you all the data here. And we can switch those around even, it looks like. And your confidence level right there. And if you wanted to do difference of paired differences, we'd have a little bit of a problem here because they don't really pair up. But if we did, we could totally mess with those too. All right, so that's all I wanted to show you. Until next time, enjoy doing math.